I just love that. Just the idea of a robot mobily moving around the world and interacting with people. It was totally a foreign concept and really cool to me. So that was probably when the seed was planted. And then other movies like Back to the Future 2, getting to see what people thought the future would be like and all the interesting, unique robotics that actually, they didn't, the timing wasn't right, but eventually a lot of them came true. That's probably the seeds for the passion. And then from there, I had, always was pretty good at math. You need a good solid math background to jump into this world, and went into engineering. Sadly, there were no robotics degrees when 25 years ago when I was in school. So I went for electrical engineering generically. But that gave me the foundation I needed to kind of go explore kind of high technology and eventually robotics.
I hear that story commonly from many people, either mechanical or electrical engineering was
Hmm.
one of the first steps to entering into this.
Yeah.
And now, then after college, what is your history around technology companies that you worked with and projects that you worked with that moved you along the path to the mobile industrial robots that you work with now?
Yeah. So most of my career, I've worked in on equipment or products that had robotics in them or automation in them, but not as the product. And so the last few years is when I've jumped over to where the product I'm working with is the robot we're selling to someone else. But I started in a capital equipment company selling to semiconductor customers, basically front end semiconductor, in the clean room, manipulating wafers as part of the process for developing chips. And so, large capital equipment, robots to move wafers around, and lift wafers up and down, and things like that. So, it was a really good introduction into robots, by having them in the products that I was working on. I actually started by learning how to train the robots, teach them their job, test, make sure that they work in the system, and then ship them out to a customer and follow them out there, set them up at the customer's site. Then I moved on to actually designing the equipment, integrating the robotics into the equipment. One of my first robotics projects was to take a robot that had been 10 years in a piece of equipment and it was being obsoleted, and find a replacement for it. And do so with very few resources to help me. And so we found a replacement robot, figured out how to electromechanically fit it in, um, uh, basically mimic the software interfaces that the other robot had to minimize the change on our software, and get it integrated and rolled out to replace the obsolete robot. That was kind of my first project, and it was quite fun. I learned a lot. So.
The engineer in me says, "Oh, that does sound like a fun project."
It was. I had no software resources at all. I basically was told we need to replace this robot and you don't get any software help. So I had to sniff the code and basically make some middleware myself, and it was cool. It was fun. So.
Now, just a minute ago, when you were talking about education background, you mentioned there not really being robotics degrees at that time. And I think there's now slightly higher number of mechatronics
Yeah.
related robotics engineering kind of degrees. But if someone was really interested in following the path of getting into robots, since you work with these kind of engineers a lot, what would you recommend for that student or very entry level engineer now? What kind of things should they be focusing on to get them a leg up in the industry?
Yeah, I think, if you could find one of the robotics degrees, we've had some good success recently with people coming out of academia with these robotics degrees. They really do provide a nice, well-rounded balance of the mechatronics, the electrical, the controls, mechanical, some materials, a little bit of embedded software and controls, sort of the whole mix that you need to be a well-rounded systems engineer in the robotic space. You could still be working in robotics and more specialized in one of those functions, though, as well, right? We certainly have classically trained mechanical engineers who are, instrumental to our design of our robots. And they couldn't program a robot to save their lives, but without them, we wouldn't have the robot. So, I do think, the system level, well-rounded degrees could be useful. But I think you can get into this from any from any of those disciplines. I I'm more passionate about the solution space, so I might steer people toward the robotics degrees, but that's not the only way.
Now, turning this back towards the mobile platforms, I want to start discussing a little bit about the technology that's involved. And I think a few people in our audience are certainly aware of mobile robotics. But since they've been around for a shorter amount of time than the more traditional industrial robotic arms, the articulated types of robots, could you provide us just with a little bit of a brief history of mobile robot platforms, how they started and where they're at today?
Or I'd say mobile robots probably started being commercialized all the way back in the 50s, I would say. Started out mostly as fixed route, kind of follow robot that follows either a track or a magnetic tape or something that gives it the direction that it needs to go. And and really that's kind of the AGV side of the mobile robot market, and it has matured quite a bit, having started from that early stage, probably around the late '90s, early 2000s. Began to see more mobile, more decision making in the robot, and so some products started to come to market where you're no longer beholden to the fixed line track or a magnet, and robots that start to understand their environment and make some of their own decisions. And that's where MiR comes. That's what MiR is. MiR was a kind of a pioneer in really accelerating the growth of that mobile market. Um, it definitely has a lot more challenges than kind of the fixed route mobile robotics. We have to really learn the environment, navigate, be dynamic, make decisions on the fly, and I think that there's a lot of emerging technology improvements in vision and AI and other areas that are making that more and more reliable. And there's still an application for fixed route robots if you're not um, changing the application frequently, or there really aren't many humans in the area or a lot of traffic in the area. That can be, a pretty cost effective solution. But trying to backport robotics into existing facilities is, where people want to automate where they didn't before. Moving that decision making to the robot becomes more and more important, and that's where kind of the latest generation of mobile robotics comes in.
Now, you mentioned the AGVs, the more guided, they follow a track of some kind.
Mm-hmm.
And so this would be a little bit of a difference. And now, is this that field that they would call the more AMRs? I hear that acronym quite frequently, of more the autonomous navigation from the robot itself rather than the track.
That's right. AMR would be the category of mobile robot that has a little bit more freedom in its decision making and how it navigates. There are a few technologies used to do that, right? On guided vehicles, generally they're following tape, they're following some kind of track, QR codes on the floor, where it just leaps from one QR code to the next. Those are sort of AGVs. AMRs generally are using some kind of LiDAR, 2D LiDAR, or vision-based system to map and perceive the world around the robot, and then generate unique plans and routes every time a new mission occurs. The robots will then often generate a new unique plan based on what it sees is in its way. So that's AMRs.
And here in just a little bit, some of those technologies that you were just mentioning, some of those concepts, I'd like to kind of circle back to that in a little bit and discuss
Sure.
those a little bit more in depth. I am curious here, as we're kind of describing the differences a little bit between these AGVs and AMRs, are there particular use cases where one is more suitable than the other? Or would you say that AMRs are just more of an evolved upgrade of the AGV?
Um, there's a gray area in the middle where it's an upgrade, but I think there is definitely some application space that they each hold uniquely, right? I'd say guided vehicles still have a place when it's you're not going to see a lot of change in the equipment that the robot's interfacing to, the routes that it needs to take over time, and there are not a lot of people in the way. It can be a cost-effective, highly reliable solution for those applications. And so I think there is that tail of the curve that's still going to always be AGVs. Uh, there are some. Let's see. I've encountered some applications where at MiR they want an AMR, but we look at the application and it's a fenced off area. There's no humans walking around. The spaces are very narrow. It's a industry that they're probably not changing the lines or the routes for 10 years. This is a very like long term thing, and we look at it and say, you know what, we certainly could do an AMR, and but in this case, given the longevity and the lack of change and the lack of people, the AGV might make sense. But as soon as you start changing any one of those variables, that's where AMR value starts to really unlock. And so, remove those fences, and you have some people around. Well, AMRs can see the person and pick a new route, right? They don't get held up by the person or the truck or the cart or whatever it is that may be dynamic in the environment. Or if the lines change every couple of years, right? A new model of widget X is coming out in 2 years, and widget X is going to need this different layout in the manufacturing, or for that example. Well, in that case, you don't want to have to be redoing the fixed infrastructure every time your layout changes, and so then an AMR becomes more attractive. So definitely still space for AGVs, but as soon as you start having any kind of change in that environment, AMR value really is unlocked.
And as you're mentioning some of those variables, that sounds to me similar to the variables that you might experience when you're considering fixed, like a conveyance system for product handling instead of mobile platforms. Some of those variables still might make the more flexible solution of an AMR a more appealing, based on some people's more traditional view of conveyance and material handling, just moving on conveyor belts or tracks from one place to another.
Yep, exactly. Very, very similar trade-off. And in that case, that the change of fixed automation from, is even more expensive than the change of an AGV layout. So it's actually the more extreme of the AGV example, right? But again, if it's unlikely to change for a long, long time, and you need, incredibly high throughput through those systems, right, where you can block them off from danger from people, they do have a place, right? They can definitely be the most the best solution for those applications where you have that.
And with mobile technology, mobile robotics, there seems to be two distinct types of scopes where these robots are used. And we've been discussing some of the more industrial applications where it's moving the widget or transporting around a factory floor. But there's also the service industry. And maybe that kind of goes back when you're talking about entertainment industry and movies, and maybe many people's introduction to mobile robots was R2-D2 as a service robot on the sail barge. But can you explain just a few of the design differences, between these two different scopes, the ones that are more intended for service versus more intended for industry? They may be mobile, but I imagine there's many different design factors that make these two quite different when you actually get down into the design stage.
For sure, certainly the safety standards that you're required to comply to are written quite different between the service industry, service robots, and industrial robots. It's kind of assumed in an industrial application, an industrial setting, that there's the opportunity to educate and train those who are working in and around the robot about its right of way, and what to expect from that robot's behavior, and then you can rely on that training of those people to be able to maybe drive a little faster, or make those assumptions around it, and those safety standards kind of have that assumption built in the service industry. You don't have the luxury of assuming that you've been able to train anybody that's walking in and around the robot. And they have a toddler running up to it from any angle, right? And so there certainly are design elements that have to change, although a lot of them are similar. It's just the level of cautiousness in the design, the threshold for decision making. It's a lot safer. The service robots are going to move much slower. They're going to pause when they see something moving in the environment around them much quicker than maybe an industrial robot might. The user interface has to be, intuitive, because you don't have that training opportunity. So, if you're expecting that service robot, I think I saw one. I was at an airport lounge the other day, and there was one moving around, asking you to put your empty dishes in it, right? And so it had a good user interface. It looked like a trash bin. It had signs on it, and I just knew what to do. I didn't have to be told you can put your trash. When I walked in the lounge, they didn't say, and be sure to use that and put your trash there. It was very intuitive, right? So the user experience, it's a different world when you're dealing with the general public versus kind of trained operators in a more industrial setting. I think those are probably the big, but the underlying technology, the use of LiDAR or vision systems, feeding those back into a safe compute solution, either a safety PLC or some kind of redundant embedded safety solution. Those are still pretty much the same technology underlying. It's just that threshold for safety is a bit higher in the service space, and that user experience needs to comprehend the general market, just general user. So.
And after seeing a lot of companies that, well, most of the time I attend trade shows that would more specialize in the industrial space, but I've also seen some companies that specialize in more of this service or entertainment industry. But very rarely do I see companies that produce both kinds of robots. And I've always thought the underlying technology seems similar enough that there must be a reason that companies do tend to specialize in one type of application scope over the other. Would you agree with that? Your experience here is certainly far more developed than mine.
Yeah, for sure. We at MiR have looked at that space a few times to evaluate its applicability. It's not, while there is a high degree of technical overlap, the go-to-market is quite different, right? So, a lot of times your sales channels and your integration partners and the customers that you're good at servicing, it's just very different in that kind of B2B industrial space than it would be in the service robot industry space. In some cases, you're selling directly to a very untrained user on what is automation and what is robotics, and we've sort of, at least for MiR, one of our specializations is in our channel, our go-to-market, right? How do we foster partners that kind of attack the right industries for us and can service, big, large business to business kind of customers. And we just don't know a lot about, the service robot go to market, right? So some of it is just that, right? It's just a very different go to market. But yeah, I would agree. The underlying technologies have, a lot of overlap. And so I wouldn't be surprised if we didn't start seeing some M&A or some mergers in that space, because there could be some synergies to be had between companies that operate in those spaces, for sure.
Keynote speakers and live sessions for Control Automation Day are brought to you by Mouser Electronics. As your design fulfillment distributor, Mouser is your authorized source for millions of components from over 1,200 leading brands. Come discover, design, and develop with us. Now, as MiR has been evaluating some of these different potential target industries, do you feel that there are any that might be kind of looming on the horizon, or any currently emerging industries that will provide opportunities for mobile robots maybe this one focusing a little bit more maybe in our industrial space, since that's a little
Mhm.
bit more related to the scope of our chat today. But some of those emerging industries where we might see more use of mobile robots in the future.
Yeah, I think right now it's pretty centered around manufacturing, logistics, which is generic enough to cover almost anything, really. But for sure, I think the food and beverage space is probably not fully tapped yet for mobile robots. I think there's some technical challenges around, you know, operating in clean and cold, extreme environmental conditions you might find in some of the food and beverage space. Might require some technology shifts to go jump into those markets. Even the logistics markets, there are a lot of kind of e-commerce robots, which actually is a bit of a different space than what MiR plays in. So e-commerce is kind of uh, bringing goods to a user to be picked and interfaced with that user, um, or or bringing following the user around as they pick things from a shelf, right? So that is kind of a class of mobile robotics where there's companies who have specialized in that. And in that area, you don't require a lot of precision. The robot's not having to interface and dock to things. They just kind of have to move near a human. And a lot of that space requires incredible integration with a factory management system, right? The e-commerce logistics knowledge of inventory and where to go and the flow of robots. So that's kind of a class that exists and is growing rapidly. And then whereas MiR plays a bit more in um, the industrial material movement to line side or off of the line side to staging location, and in that space, yes, we'll have connections to manufacturing systems to know when to do what job, but generally it's not as integrated as an e-commerce. And but then precision becomes important. So a lot of times, mobile robots need to dock with a mobile conveyor to transfer material onto a conveyor. So now we're having to dock with, you know, 5 centimeter accuracy. In the e-commerce space, you can stop with plus or minus 50 centimeters, and it'd be okay. So that doesn't quite answer your question of what's growing, but it is a class of mobile robotics that should probably be differentiated. Is that e-commerce space? But yeah, I mean, I think, like I said, food and beverage is an interesting vertical that certainly is untapped, and I think MiR plays in almost every other every other space other than that right now. So
And another one that I've heard many companies mentioning, but I haven't seen quite as many applications yet, is healthcare industries. And I know
yep,
that's becoming more and more popular for mobile platforms. But those probably, in some cases, you mentioned some of the challenges that are faced with entertainment and service robots. And I would
yeah,
imagine that in a hospital type of environment, you face a lot of those same challenges when working around employees.
for sure. Yeah, there's a lot of healthcare kind of back end jobs that MiR is involved in, where it isn't the general public. But for sure, there we get a lot of requests for moving uh, carts of um, materials to rooms, or even delivering the food, and oftentimes those involve transversing an elevator, right? Go down to the basement and get something and go upstairs. So there's other technical challenges there. But that certainly is it starts to cross into the service robot space, because generally in the healthcare space, the general public is allowed. So that is almost more of a service application.
During the project design phase, you mentioned some of your earliest projects had to do with upgrading and replacing robot systems.
Mhm.
But now, having worked with mobile applications, what would you say are some of the main differences that design engineers face when they're having to convert now and work with a mobile platform instead of having like a fixed robot arm that's bolted down to the concrete? I imagine there's a lot of changes in the design process that must be faced.
The solution design, you mean, right? Yeah. So I would say fixed robotics, you have you certainly don't have to care as much about the environmental conditions. or interactions with other robots. Or if you do, you're able to design it in a around that very specific uh, topic and then set it and forget it, right? Whereas mobile robotics, the environmental conditions become critical, right? If there's a stairway, we need to be aware of what to do around a stairway. If there's a high traffic area with lots of fork trucks, then we need to design the routes and the behaviors in that area. We have to identify that area first, and then design the best solution for getting the robot through that space. And the number of uh, unique design solutions you have to employ, it can grow exponentially, right, as you add robots and increase the size of the space. And that's not in fixed robotics. It's a much more fixed problem. You know, bolt it here with the right torque, teach the robot to do X, Y, Z, perhaps interface a very simple I/O to trigger an upstream or downstream process, and you've got a robotic cell, right? And in mobile robots, you have all of that, but you also have to deal with the traffic, the environment, and then those other topics. So it can get much more complicated than fixed robotics quickly. But once you get there, it's a pretty autonomous, flexible solution that can run, you know, at pretty high reliability. So but that upfront design work and that assessment is really key. If you just try to deploy 30 mobile robots and give them their points in space, you'll struggle. You have to go through and think about all the permutations of what could go wrong as you design the solution.
And in this case, I suppose asking about design differences is a little bit of an unfair question in this scenario, because aside from the word robot being shared between fixed
Yeah.
articulated arms versus mobile robots, after calling it a robot, that's pretty much where the similarities end.
Yeah, I mean, you know, there's mobile robots like MiRs that are a base robot that can have a unique top module added to them. It's kind of like an end effector being added to a fixed robot, right? So there's a parallel there. But the thing that you're adding onto that top module isn't just a gripper, right? Usually it's, you know, a whole conveyor, right? You know, sometimes we mount robots to the fixed robots to the mobile robot, right? So now you're doubling your challenge. So, but yeah, it's I mean, there, you know, sometimes mobile robots will interface with PLCs as their mechanism of handshaking, you know, information. So there's some overlap in kind of the interface technologies, but it's definitely it's got a lot of complexities that fixed robots don't have.
And one technical aspect that, again, we'll return back to in a little bit, but one of my favorite topics in automation is that of communication, whether that's hardwired communication, wireless technologies. And so certainly the thought of a mobile platform where now both the power and the communication signals must be wireless certainly introduce a lot more opportunities, but also a lot of concerns that certainly aren't there in a fixed platform where you can just run wires when you need to
Yep.
establish a channel of communication.
For sure. On the power side, when you're sizing an application, you know, it needs time to charge. So you have to figure out where should I charge it? How long does it need to charge versus the expected demand on the robot? And each application is a little different. You know, you may have 10 robots to 2 chargers because the distance traveled is long, but there's long breaks in between. Or you may have to have chargers on both ends of the travel because there's going to do a job down here, travel a long way, do a job there for a while. So that solution design around how and where to apply the power is an interesting one. There's also more and more opportunity charging solutions coming out on the market where you can charge while you're doing the job to try to minimize some of that. But that is a big factor on getting power. And then communication, and I should have mentioned it, the other complexity, of course, in traversing an environment is relying on a wireless network. And that is uh, that can be challenging. A lot of customers will simply want to latch on to the existing Wi-Fi infrastructure, and that can work in many cases. But a lot of times, the solution wasn't designed expecting to have to uh, pass a robot from one access point to the next, and everybody sets their Wi-Fi up just a little differently, and so there are configurations and optimizations that you need to do. Um, and we our robot deployment teams have become experts at doing heat maps, Wi-Fi heat maps, bringing in third-party tools to walk around a facility and point out, these are the strong areas, these are the weak areas, and so selling mobile robot solutions, you end up developing some expertise in in Wi-Fi for sure. So.
Well, we'll come back to some more of those communication technologies in just a second.
Mhm.
But a few of the specific things that we've talked about that set these mobile robots apart. I know one of the words that I hear very often from all kinds of automation, but particularly from mobile robot fleets, is this term scalability, the ability to
Mhm.
scale a fleet. And I was just wondering if you could define that just a little bit and explain what does that mean, and what are the differences between scaling, starting with one robot and then increasing to two in a fixed discrete automation cell. You simply set up another cell right beside the existing cell and
Mhm.
copy some code function blocks. But I hear this so often in mobile fleets and fleet management that there seems to be a lot behind the concept of scaling and making that easier for the customers.
For sure. I think if you look at the journey of an AMR customer, most of them start in kind of a lab phase where they'll buy a couple of robots and learn about it, set it up to do a job like it's a fixed robot, and then assume, oh, okay, now I get that, I understand it. Now it's time to scale, and they'll try a pilot site where they'll do 3 or 4 robots, and okay, there's some complexities. Robots have to interact with each other here and there, and we don't want to have them have any kind of collisions or deadlocks with each other. So you have to design their routes so that they play nice together, and that works pretty well. And then they'll try to scale to like a bigger application of 20, 30 robots, and start to realize, oh wow, yeah, this is it isn't just copy and paste a robot cell 20, 30 times. The complexity does start to increase proportionate, or sort of exponentially with the number of robots. And a lot of that gets down to traffic management. If you have big wide open spaces and those 20 or 30 robots are spread way out, maybe it is a little bit like copying robot cells, especially if they're doing unique work. But if it's much more congested and the density is much higher, you have to take great care to make sure that the routes they're taking are logical. Oftentimes, a mobile robot isn't just doing one job, it's doing one job and then bringing material to where it's going to have the next job and then the next job. And so designing that mission flow becomes not just the one thing it's doing, but it's what are the one thing and then the next 3 things that it'll be doing. And how do I make sure that the right robot is picked for the right job, right? And so there is a bit of configuration and setup to make sure that um, the the right robots are being picked at the right time for the right job. A lot of that we can handle in the back end, but some of it does need configuration and setup based on the application. And so that's, yeah. And then to get to true scale, um, where now you're 50 plus, 100 plus in one space, there's just a lot of interoperability concerns, right? Okay, so now robots are interacting with more and more people and things, and I want to be able to, in one consolidated way, uh, be able to view the health and understand the health of this huge fleet. If it's a few robots, the solution to monitor them and keep their health and their uptime can be pretty straightforward. But as you scale that to hundreds, you start to need notification systems. How does the person tracking know which robot to go look at which time when there's a problem? becomes a bit more complex, and so there's quite a bit there. So as customers go through that journey that we've noticed from this lab to scale, at first there's a lot of concern about the architecture, the job, the solution. What is the ROI, right, of this one application? And then they try to scale it. It's like, okay, how do these robots then collaborate with the other things in the environment? How does the networking becomes more important? Then another element of scaling. Now the solution is not just living on the floor, but there's so many robots. There's usually a fleet server. So now we have to go talk to IT and deal with the server room. And are we going to run the fleet on an on-prem server, or is it going to be a cloud server servicing multiple locations? That becomes a consideration, right? So there's just as you get bigger and more, the complexity does grow. And elements of, is it repeatable? How maintainable is it? What is the uptime? Start to just really become important when you get to a lot of robots.
So as they're being integrated with their environment, now I guess that there's the fleet management software that they have to interact with. There's probably some basic element of connection to a control system. Probably some warehouse management software or system at play. What are the different kinds of software that you've seen or experienced these fleets having to interact with? Because when I contrast that, like a robot that's tending a CNC machine, the most it has to deal with is a start and stop signal and a door switch. It's very basic communication. It sounds like there's tremendously more at play here.
There is, although not every application. There certainly are some that can run that same way, right? A PLC register to flip an IO bit can trigger an action and go take that action, or I need to trigger that door to open. So when I reach this position in the map, I communicate to a PLC and open that door in the map. So that could be very closed loop. And smaller applications, some customers will send the orders or send the jobs with just a simple user interface that the vendor provides. Start mission A with robot, go, right? And there's really no knowledge above that, right? But again, when you get to scaling and you get to logistics and some of these manufacturing sites where there's already a level of maturity in how they run their flow, AMRs need to plug into that, right? And so communicating to MES becomes, or where manufacturing execution systems or warehouse management systems becomes important. And often, that communication can be as simple as being told, okay, there's an inventory here that will need to move there at this time, and then the fleet manager can absorb that information and be an intelligent fleet management system to do what it wants. Or some of these MES systems or warehouse management systems are so complex and integrated to the rest of the business systems that they just want to say, go do this order with this robot at this time. And so that software interface to that warehouse management system needs to be, as a vendor, needs to be very open and flexible so that we can adapt to these wide range of solutions. And so generally, the strategy that MiR takes is we have a pretty open API that provides hooks into all of the function, many of the functions of the robot, and somebody has to write some middleware to plug that into the particular application, specifics of that warehouse management system or that customer's needs. And so that's how we've, as a vendor, we've just given as an open API as we can, and then through application support, we work with either our integration partners or some of the big SAP. They'll have integrators who know how to do those integrations, and we'll work with them directly. But it can get pretty complex pretty fast. Having to, as a vendor, we struggle because there's so many permutations out there. If we optimize to one, we wouldn't be able to service the market. So really good, solid APIs has been our strategy, but that requires an integrator to develop some software capabilities where they may not have had to have in the fixed robotic space.
So the next aspect of the technology that I really want to dive into a little bit more is the mapping localization, hardware maybe and software. The last year or so, I've seen so much more AI based vision systems, but then there's also
Yep.
LiDAR technology. And there's a number of different ways that environment detection can happen, because obviously that's what sets an AMR apart. So without going into things that may be so cutting edge that you can't really discuss some of the newest stuff that you're using, but I am curious, what are your thoughts on what technology is most at play right now? What are some that provide some of the best advantages or strengths and weaknesses from some of the different localization and mapping solutions that are available for AMRs?
Sure. I think 2D LiDAR is still the bulk of what's on the market, just because it's tried and true and fairly reliable. Um, you'll that's I think you'll still see a lot of that. Mostly is what's in the market today. And this is just taking a plane of 2D points, driving the robot through the entire facility to create a mapping of what it sees for fixed objects, and then either doing some manual manipulation of what you've mapped to confirm what is a fixed object and what happened to be a person that time you drove through. Um, uh, and that kind of gives you a baseline in that 2D plane. Um, and then once you have that established, robots can drive through that same area and kind of keep that map continuously refreshed and updated in case things move a little bit. Robots can share that information and keep yourself accurate. And it works pretty well. Being only a 2D plane at a certain height off the floor, you're missing a lot of information that's out there. And so sometimes it can result in difficulty navigating in either highly dynamic environments, or environments where the quantity of fixed features in the view of a LiDAR is actually at a kind of a low density. Think wide open warehouses, right? Um, and it's kind of those use cases that are driving the market toward some more advanced technologies to provide a kind of richer sensor input into how we know where we are, how we localize where we are accurately, and then how we move against that. So certainly visual SLAM and using vision is got kind of the next level, I'd say, of maturity. There are companies out there doing that, and doing it well. It has its own challenges. Lighting becomes a challenge. Any challenge you have with vision and with cameras, you have to figure out how to absorb and take into account. Um, and but it's definitely shows a lot of promise, and certainly there are some of the leading edge vehicles out there driving strictly on on vision, and so we know it can be done. We know it can be done in harsh environments. We know it can be done well. Mobile robots, we have to do it with sometimes a level of precision you don't see in kind of automotive. Um, and so that's the area that we need to make sure that there's enough resolution coming back from vision, that we can use that information to dock accurately when we need that precision. There are other sensor technologies. 3D LiDAR is simply taking the 2D plane and extending it to many slices of 2D, and that can provide you a lot more information and input, and doesn't have some of the challenges with vision. Um, and so that's an interesting area. They're still a bit expensive right now, 3D LiDAR, but certainly gives you can give a much richer feedback into the environment around. I think with vision and with 3D LiDAR, there's the opportunity to layer on some more intelligent machine learning and AI. A little bit less so with 2D LiDAR. With vision and 3D LiDAR, you can start to recognize what an object is and actually make unique decisions based on your perception of what that object is. So, and I think that'll have a lot of value going forward in sort of increasing the reliability of driving in these dynamic environments. And so there's no question, I think, fast forward 20 years, you won't see the peak um, of AMRs in the market using 2D LiDAR for sure. But I think the level of reliability that's required in these industrial applications is very high. And so I think it'll take a bit of time for those technologies to mature and stabilize enough that we can rely on them in a 24 by 7, production critical application.
Now moving back to my favorite topic in this whole thing, that of communication. You mentioned Wi-Fi, some of the strengths and weaknesses of Wi-Fi, which I imagine are probably somewhat familiar to most people in an industrial environment. They know of some of those challenges. I've seen a lot of development in industrial 5G networks. What
Mhm.
would you say right now are some of the different ways? Maybe again, there's some with some strengths and weaknesses. There's probably some emerging technology that may not be mature yet, but I'm just curious right now, what sort of communication systems are the ones most being relied on for mobile applications?
So 5G is really interesting. There are some mobile robots in the space that have been working on 5G only solutions. The value of 5G, and for a certain size of and commitment to industrial automation, I think a lot of companies are going to go that route, right? Hundreds of robots in an application, where you want high uptime, high availability, and I think 5G is today already in some cases being deployed. Um, there are also potential applications that can get unlocked in the future when you have the speeds and the latencies and the bandwidth of 5G, that we're not even scratching the surface of yet today, where we can move much more data back and forth between robot and central decision making, when we're on 5G. And so we're excited about the potential future of that. But still today, just so many people have the existing infrastructure of Wi-Fi networks that unless you're ready in a greenfield application, a greenfield building, ready to make that leap, very few are willing to make the change. There isn't kind of enough value, and so we are kind of struggling with the legacy, Wi-Fi, but it can be tuned to work well, and we've found, if you're ready to focus on that, you can tune it to work well for sure.
Yeah, the discussions of different technologies and looking forward to the future of where they're going to be used is really fascinating. Now, before we're
Yeah.
done with our time today, I want to kind of address the needs of a couple of different audiences who might be looking at getting started with mobile applications. So those being perhaps the end users who their own facility is the one that they're considering how to take the first steps in developing robot applications. But then there's also integrators who are going to be more the
Mhm.
developers and managers of the fleets. Would you be able to provide kind of one key takeaway for each one of those audiences, and something that if they're thinking this may be an upcoming next step in their automation journey, something that they can do to prepare for that as easily as possible, kind of an action item that they can do right now?
Sure. End users, the 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 the, the biggest takeaway I think would be, don't bite off more than you can chew from day one. I think, the potential of these solutions is so great, and the labor supply challenges that people are facing are pushing people to just jump in and push through. And based on a lot of the things we already talked about around making sure that you've designed the environment, you understand what it's going to take to run mobile robots in your application. Um, you make sure you've done that homework, um, and we can help. Use the vendors, right? Don't. I think too often companies that have especially familiarity with fixed automation assume that they know automation enough and can jump into mobile robotics without a lot of help. And in most cases that's not true. It's a learning curve. It's a new learning curve, just like anything else. And so, um, the best way to get started is get a unit, get a proof of concept, get your hands dirty, go to the training, um, you know, meet with a few vendors, meet, but but don't just meet with their salespeople. Like, meet with the applications team, walk them through, have them walk you through, like, what are all of these? What would the site checklist be for me to be able to make use of this? Like, what are good applications? What are bad applications? Don't try to go it alone. I think that would really be my biggest takeaway for an end user, because there's no question the potential's there, but end users can get soured on solutions very quickly if they try to run before they walk. And so, that would be kind of the end users. And integrators, it's not that dissimilar. We've seen some integration partners who are some of the best in the world at fixed robotics jumping into the mobile robot space and kind of getting surprised by how much uniqueness there is in designing these solutions around scaling and around environmental considerations. And I think take the training, do some smaller and medium applications, and convince yourself you're ready to go big before you go big. I think that is super important. I don't think there's a lot of new or unique technology you need to go learn. I think it's yeah, there's some understanding of Wi-Fi that you may not have had, but you can rely on the vendor for that. As an integration partner, yes, there might be some middleware software that you have to write that you've never had to deal with before. If you're going to go after segments that have that requirement, you may need to find some people that have those skills that you don't have already. But a lot of the vendors in the mobile robot space are used to having to bring people along that journey and can provide a lot of in-depth application support and expertise. And so a new integrator getting into the space, use that application support. Use the vendor heavily. Don't try to jump out on your own based on your experience with fixed automation. That's probably the biggest caution that I would put out there to an integrator.
Well, thank you very much. Your experience and your time is just very valuable, and it's really interesting to listen to this area of robotics that is probably a little less familiar to some people who are more traditional robotics based. And I do have one last question. Sure. This one's more of a for fun question. So this one's for you. If money was absolutely no issue and you could buy any techie toy gadget thing that you wanted, what would that be?
Oh my. I would say any one of the more advanced humanoid robots to come into my house and pick up after my kids. But seriously, I mean, those humanoid robots just are. I don't know how they're going to monetize that and go commercial with it in sort of this space in the consumer space, but I'd love to get my hands on one to play around with. Just have it go walk around and mow my lawn. Program a humanoid robot to mow my lawn. That would just be so cool. So yeah, I think that would be, and it's certainly not something I could afford anytime soon. So that would be it.
Well, again, thank you very much for your time. This was a great discussion. I really enjoyed learning from you, and you certainly explained a lot of questions that I had around the whole mobile robot space. So again, thank you very much. This was a great discussion. Thank you for your time.
Awesome. Thank you so much. Appreciate it.
And thank you to our audience for joining us today for this keynote, sponsored by Mouser Electronics. And once again, our sincerest thanks to Mobile Industrial Robots and to Kevin Dumas for sharing his time and experience with us. We hope that you will visit the virtual vendor booths and watch the other keynotes and live session events, all of which will still be available on demand after today, so that you can share the experience with anyone who may have been unable to join us live. And remember, the more sessions you register for today, the better your chances of winning one of our giveaways or becoming the lucky winner of our grand prize of your very own 4-axis robot arm. Thanks for joining us for this Control Automation Day 2024 presentation.